After dry test tube heating, we have to go for the next step, that is identification of acid radical. In this step, we have to perform two types of test. First of all, dilute sulfuric acid test, and second of all is concentrated sulfuric acid test. First, we go for the dilute sulfuric acid test. We take the sample and pour some dilute sulfuric acid to it and change. If any changes occur, we can observe the changes. For this test, we need dilute sulfuric acid, lime water, our sample, and test tube holder. First, we go for the test for carbonate anion using dilute sulfuric acid. For this test, at first we take the sample in a test tube. We place few drops of dilute sulfuric acid in it. If any gas evolves, we pass this gas through lime water. Again, for the test of acetate anion, we do the dilute sulfuric acid test. We take the sample and add few ml of dilute sulfuric acid over the sample. Here we can see that no effervescence of gas occurs. Then we have to heat the sample over the flame. After heating few minutes, we can see that here evolution of colorless gas occurs. When we place a blue litmus over the gas, it turns red. That means it may be a acetate ion which turns the blue litmus red. Here we can note one thing, that for dilute sulfuric acid test, if no colorless gas occurs, then we have to heat the sample gently. These changes occur due to the acidic property of the acetate ion. Now we go for test for another acid radical, that is identification test with concentrated H2SO4. For this, we have to take the sample and pour concentrated H2SO4, 2 or 3 of concentrated H2SO4 on it. If no characteristic changes occurs, then we have to heat the sample over flame. On heating, we can see that a white fumes appears when a glass shot dipped in ammonia placed over it. It produces white fume. Here you can see the colorless gas produces white fume on contact with the glass shot dipped in ammonia. That indicates the gas is a chloride ion, and here chloride ion is present in our sample. Another part of the sample, if we pour few drops of concentrated sulfuric acid, we can see that a reddish brown vapor appears. If we place a glass shot dipped in silver nitrate over the mouth of the gas, we can see a white glare on the glass rod. Here you can see that a white or yellow glare over the glass rod mouth. This indicates the presence of the bromide ion in our sample. Bromide ion on contact with the silver nitrate solution, it produces silver bromide which is yellow in color and produces a glare on the mouth of the glass rod. To the another part of the sample, if we place few drops of concentrated sulfuric acid, we can see that evolution of violet gas occurs. For rapid evolution of the gas, we have to heat the sample gently and place a starch iodide paper that is moist in water over the mouth of the gas. The blue color, deep blue color of the compound, that is starch iodide paper, indicates the presence of iodine in our sample. Again, to another part of the sample, on a test tube, we place few drops of sulfuric acid on it and heat the sample over the flame. Here we can see that a reddish brown color vapor is evolves, which indicates the presence of the nitrate or nitrate ion in a sample. After identification test of acid radical and basic radical, we go for the confirmatory test of the acid radical. Now, for acid radical confirmation, we go for the test for carbonate as magnesium sulfate test, chloride for silver nitrate test, manganese dioxide test, and for bromide we will perform silver nitrate test, manganese dioxide test. From iodide we will perform silver nitrate and manganese dioxide test. For nitrate ion we will go for the starch iodide test, and for nitrate ion we will perform the brown ring test. For acetate ion we will perform ferric chloride test, and for sulfate anion we will perform the barium chloride test. By this above test we will detect our acid radical present in our sample. Start. Now, for the confirmatory test of carbonate ion, we need magnesium sulfate solution, sample, test tube, and test tube holder. Now, at first, we dissolve the sample into distilled water. After dissolving the sample into distilled water, we add few drops of magnesium sulfate solution into the sample. Here we can see that white precipitate which indicates the presence of the carbonate ion in a sample. This is a confirmatory test of carbonate ion. Now, for the test of chloride ion, we dissolve the chloride sample into a distilled water and divide it into two portions. With the first portion of the sample, we prepare silver nitrate solution, which I am pouring into it. Few drops of silver nitrate solution is added to the sample solution. Here you can see the clear precipitate of silver chloride, which is dissolved in like an ammonia. The precipitate is dissolved when we add ammonium hydroxide to the solution, which confirms the presence of the chloride ion in our sample. For the another part of the salt, we take solid sample into a test tube. Then we add to the solid sample pinch of manganese dioxide and add concentrated sulfuric acid into the mixture. After this, heat the mixture over flame. Pungent gas evolves which turns the starch iodide paper blue, indicates the presence of the chloride ion in our sample. This is the confirmatory test for chloride. For the confirmatory test of bromide ion, take the sample in test tube, add few drops of distilled water to dissolve it, then add few drops of silver nitrate solution to it. Here we can see the yellowish precipitate. The color must be distinguished. This is for the chloride ion and this is for the bromide ion. My left hand indicates the bromide ion precipitate, which is yellowish in color, and the right hand indicates the chloride ion color, which is pure white precipitate. This precipitate is soluble in ammonium hydroxide. The precipitate clearly soluble in ammonium hydroxide. That is, the precipitate becomes for the bromide ion. This is the confirmatory test of bromide ion. There is another confirmatory test for bromide ion, that is manganese dioxide test. For this, we have to take the solid sample in a test tube, add pinch of manganese dioxide in it, then add few drops of concentrated H2SO4. Formation of yellowish brown gas, which turns the starch iodide paper blue, indicates the presence of the bromide ion. The yellowish brown gas, like nitrogen dioxide, which turns the starch iodide paper bluish, indicates the presence of the bromide ion. Here you can see the color of the starch iodide paper becomes yellow. This becomes yellows in color, indicates the presence of the bromide ion. For the confirmatory test of iodine, take the sample solution, then add few drops of silver nitrate solution to it. Pale yellow precipitate indicates the presence of the iodine in our sample. This precipitate is again soluble in ammonium hydroxide solution. We have to add sufficient amount of ammonium hydroxide to dissolve the precipitate. On addition of liquor ammonia, the precipitate dissolves. We have to add sufficient amount of ammonia to dissolve the precipitate. Here you can see that the precipitate had dissolved completely in liquor ammonia. That indicates the presence of iodide ion in our sample. Another confirmatory test for iodine is manganese dioxide test, like the other halogen. For this, we have to take solid sample in a test tube, a pinch of manganese dioxide in it, add few drops of concentrated sulfuric acid, and heat the mixture over flame. The violet color glass evolution of violet gas which turns the starch iodide paper yellow to blue. Now the confirmatory test for nitrite ion, that is starch iodide test. For this test we require sample, dilute H2SO4 solution, starch solution and Ki solution. At first we have to take the sample in a test tube, make it dissolve into distilled water. After that, add few drops of dilute H2SO4 to acidify the solution. After acidifying the solution, add few drops of Ki solution to it. Then add freshly prepared starch solution to the mixture. Formation of deep blue color. The color seems to be black, but it is originally bluish in color. We can see the color bluish after dilution. Here you can see the color is not black but blue enough to pass through the light. The blue color of the solution indicates the presence of the nitrite group in our sample. This is the dilute solution, which is clearly seen that it is a blue, but for this solution it may be seen black through the camera, but is originally bluish in color, that indicates the presence of nitrate group in our sample. Now the test for the nitrate anion. This is the brown ring test. For this test we require sample, concentrated H2SO4, freshly prepared clear sulfate solution and distilled water. At first we have to dissolve the sample in minimum volume of the water. After dissolving the sample in water, we add few drops of freshly prepared clear sulfate solution. Here you can see the brown ring at the junction of the two layers. Since H2SO4 is highly dense, it goes below of the solution and the mixture solution is above, and there we can see a brown ring at the junction of the two liquid. This brown ring confirms the presence of the nitrate ion in our sample. Do not shake the mixture, so the ring can be destroyed to give a clear solution. Now the test for the acetate ion, that is ferric chloride test. For this test we need ferric chloride, dilute HCl, distilled water and filtering unit and heating apparatus. Now for the test, at first we take the sample and dissolve it into distilled water. Then add few drops of ferric chloride solution into it. If any precipitate occurs, then it has to filtrate through the filtering unit. If no precipitate occurs, then we need not to filter it. Now heat the solution. After heating, if any precipitate forms, then filter it. Here no precipitate occurs, then we need not to filter the solution. Divide the solution into two parts. To one part of the solution, add dilute HCl. Disappearance of the reddish color confirms the presence of the acetate ion in the solution. To the another part, add distilled water and boil it over water bath. Due to absence of water bath, I am heating it in the flame. You have to cautious about that. During heating in the flame, the bumping of the solution may occur, so don't heat directly. After heating the solution, if no changes occur, that is reddish brown color persists for a long, or any precipitate occurs, then it confirms the presence of the acetate ion. Here we can see that color reddish brown color does not fade off. It persists for a long. It indicates the presence of the acetate ion in our sample. Now for the test of sulfate anion, we need the sample solution and barium chloride solution. That is barium chloride test. For this test, we take the sample solution in a test tube, then add few drops of barium chloride solution into it. Formation of white precipitate indicates the presence of the sulfate anion. This precipitate does not dissolve in concentrated HCl. Confirm the presence of the sulfate anion. Does not dissolve in the concentrated HCl. After addition of sufficient amount of concentrated HCl, the precipitate does not dissolve. This confirms the presence of the sulfate anion in our sample.